Today, we are pulling back the curtain to investigate the hidden culprits behind some of the world's most devastating diseases. Now, these aren't your usual suspects. They're microscopic, they're sneaky, and they live in our food, our environment, and even inside our own bodies. So, let's get into it.
Just think about that for a second. We spend so much time talking about things like genetics and lifestyle when it comes to heart disease and cancer. But what if there's a huge piece of the puzzle we've been missing? What if these diseases are actually the final act in a long-term assault carried out by these invisible accomplices?
And the stakes here, they couldn't be higher. We're talking about cardiovascular disease being the #1 killer on the entire planet. And liver cancer, or HCC, claims over 600,000 lives every single year. These numbers are just staggering, and they hint at a war being fought on a microscopic battlefield.
All right, so for our first case file, we're actually going to look inward, deep inside us, within the trillions of bacteria that call our bodies home. We're about to uncover a pretty dangerous chain reaction that can start with something as simple as a meal and, well, end with a direct threat to your heart.
Okay, now this diagram might look a little complicated, but stick with me. Think of it as a crime scene map. Just follow the trail. It all starts at the top with what you eat. That food then gets processed by bacteria in your gut, which creates a compound called TMA. That TMA then makes a trip to your liver, where it gets converted. And finally, it gets sent out into your whole body, where it can start causing damage. It's a complex process, for sure, and the main culprit here is a little molecule called TMAO.
So this molecule at the heart of it all is TMAO. And here's the thing, it's not actually in the food you eat. It's produced from the food by your microbes. Bacteria in your mouth and your gut grab nutrients like choline and carnitine, which you find a lot of in red meat and eggs, and they basically start an assembly line for this really harmful compound.
So let's break down how that assembly line works. Step 1, you eat your dinner. Step 2, the microbes, both in your mouth and your gut, get right to work. They break down those nutrients and churn out a gas called TMA. Step 3, this gas travels up to the liver, which acts like a chemical factory, converting it into TMAO. And finally, step 4, that TMAO gets dumped into your bloodstream where it can start causing all sorts of trouble.
And this really shows how TMAO wages its war. It's not a one-trick pony. It helps build up that plaque gunk in our arteries by creating these things called foam cells. It also makes it harder for our bodies to get rid of cholesterol. It flips on all these inflammatory switches, and to top it all off, it makes our blood platelets stickier, which seriously increases the risk of a dangerous blood clot. It's a multi-pronged assault, plain and simple.
For our next case, we're going to shift our focus. We're moving away from an internal process to look at some external invaders. And here we're investigating two very different assailants. One is a chemical toxin, the other is a viral duo, but they both have the same target, your liver. So our first suspect is something called aflatoxin B1. This diagram shows how it gets transformed inside the body. See, it doesn't start out as a carcinogen. The crazy part is that our own liver, through its normal metabolic processes, can accidentally convert this toxin into a super potent DNA-damaging agent.
Now, aflatoxin comes from common molds that love to grow on crops like corn and peanuts, especially in warmer parts of the world. And get this, the scale of exposure is just mind-blowing. An estimated 4.5 billion people are exposed to it. That makes it a massive global health problem, especially in developing countries. And here is the core of its destructive power. Aflatoxin literally attacks our genetic blueprint. It creates these things called DNA adducts, which is a fancy way of saying it gums up the works of your DNA. Specifically, it causes a very particular mutation in a critical gene known as P53. You might have heard it called the guardian of the genome. By damaging P53, it knocks out one of our body's most important lines of defense against cancer. But aflatoxin isn't the only threat to the liver. Meet the dangerous viral tag team of hepatitis B and hepatitis D. Now, hepatitis D is what's called a satellite virus. Think of it like a parasite's parasite. It's incomplete, it can't do anything on its own. It absolutely has to hijack the machinery of the hepatitis B virus just to replicate and spread. That's what makes them such a dangerous duo. And it turns out, how a person gets infected with these makes all the difference. If you get both viruses at the same time, that's a co-infection. There's about a 10% chance it becomes a chronic problem. But if you already have chronic hepatitis B and then you get hepatitis D, a superinfection, that number just skyrockets. Up to 80% of those cases will turn into a chronic and much more severe disease. And this chart really just spells out the danger of this partnership. When you compare it to having Hep B alone, adding Hep D to the mix just multiplies the risk of a terrible outcome. Your risk of cirrhosis, that's severe scarring of the liver, goes up 2 to 3 times. And the risk of developing liver cancer, it jumps a staggering 3 to 6 times higher.
Okay, for our final case file, we're zooming in on a single, notorious pathogen. This is the story of a slow invasion, a war of attrition that's waged over decades by one tiny bacterium against the incredibly harsh environment of the human stomach. Meet Helicobacter pylori. You've probably heard of this one. This bacterium is a true master of survival, perfectly adapted to live in the acid bath that is our stomach. And its connection to cancer is so strong that the World Health Organization calls it a definite carcinogen. It's implicated in more than 9 out of 10 cases of gastric cancer. You know, this is a fascinating visual because it tells a story across a human lifetime. The infection kicks off chronic inflammation. Then, over months, years, and even decades, that can progress to much more serious damage. But look closely at that red line. It shows the possibility of recovery. The longer the infection goes on, the lower that line gets. That's the window of opportunity for recovery, and it's slowly closing.
And here's the crucial turning point. H. pylori doesn't always act alone. The chronic inflammation it creates eventually wears down the stomach lining, which means less acid gets produced. This makes the stomach a much friendlier place, allowing other bacteria that normally live in the intestines to move in and set up shop. This new bacterial community, this cancer-prone microbiota, can then hit the accelerator on the path towards cancer.
Okay, so we've identified our assailants. We've seen their methods. It might all sound a bit grim, but this isn't a story without hope. Far from it. Now we get to turn to the defense plan. How can we actually fight back against these invisible threats with the knowledge we've just uncovered?
To take on TMAO, we can intervene at a few different points in that production line. We can change our diet to limit the raw materials the microbes have to work with. We can use things like probiotics to try and shift the balance of our gut bacteria. And there's some really cool new research on enzyme inhibitors that can selectively block TMAO production without just wiping out all our good bacteria.
Defending the liver really takes a two-pronged approach. For aflatoxin, it's all about prevention. Better agricultural practices, proper storage, treating crops to stop that mold from growing in the first place. And for the viral threat, we have an incredibly powerful tool, the hepatitis B vaccine. Because remember, hepatitis D can't survive without B, so vaccinating against HBV effectively protects you from both. It's a 2-for-1 deal.
And finally, for that stomach invader, the strategy is direct and effective: eradication. Treating the H. pylori infection with antibiotics is a powerful cancer prevention strategy. And as a bonus, once H. pylori is gone, the stomach environment can start to heal, which allows a more diverse and healthy community of bacteria to move back in and restore balance. So, as we wrap all this up, we're left with one big question. When we now know that our heart health is deeply connected to our gut bacteria, that liver cancer can start with something as simple as mold on our food, and that a stomach bug can be an accomplice to cancer, how does this change the way we see health and prevention? It tells us that the battlefield is much smaller and the connections are way deeper than we ever imagined.